Hey guys, hope everybody's doing well. Hope the AP exams went well. We're ready to get going here. We'll just have a couple lessons here of some Calc 2 leading you through the end of the school year. The first one's going to be on volume, finding the volume of a figure, and this is the shell method. So we've already seen disc, washer, taking cross sections, all enable us to find the volume of a three-dimensional figure. This is using the shell method, and we're going to break it down for you, give you a couple examples. You're going to see a lot of comparisons as to the ones that we've seen just before the home instruction began. None of that was on the AP exam, so we're going to have to kind of kick back and remember, kind of reference that and remember what we're doing here. So what's a cylindrical shell? You can think of it as a can. Here we have our can, but it doesn't have a top and it doesn't have a bottom, okay? And what we're going to be doing is we're going to be finding the volume of this can. So think of this can, again, with no top, no bottom. We cut it from top to bottom and we open it up, and what it's going to create, it's going to create a rectangle. And that rectangle is going to have a little bit of a width, and we know from past experience that we're going to call that the change in y or change in x, delta y, delta x, okay? And that's the thickness of the can, if we go back to the can, okay? Now this h obviously denotes the height of the can. If we were to cut this can from top to bottom and open it up, okay, that would also correspond to the height of this rectangle. So this would be the height here. The length of this rectangle, if you can think of this being wrapped around, would be the circle portion of this cylinder, okay? And we know if we were to start here and we wanted to find the distance all the way around, that's also known as, that's right, circumference, okay? So the length of this rectangle is the same as the circumference of a circle, which would be 2 pi times r. Okay, so what we're going to do is find the volume of one of these shells, and obviously we want to find the entire three-dimensional figure and the volume that this can actually has. So we're going to take an infinite many number of shells, and then we're going to add those volumes up, okay? And we're going to talk a little bit about that, showing the notation that you would use. So the volume of one shell, as we said, would be 2 pi times r times h times the thickness, okay? Because we know that the volume of a shell would be 2 pi times the radius times the height, okay? Times the thickness of this piece of one shell. Okay, now notice that we have dy or dx. It depends on which axis or which axis of rotation that we're going to be rotating around, and we'll talk more about that when we get there. The volume of the solid cut into an infinite number of shells, and this is where the calculus comes in. Okay, we know this is summation. Okay, infinite meaning an integral, so we're going to integrate. Okay, we'll have boundaries here. Here everything is in terms of x. Here everything is in terms of y, but that's what that notation means there, okay? So the general formula, we're going to make a representative rectangle, okay? And we can see down here in our examples that we're going to get to, our representative rectangle is always parallel, okay, to the axis of revolution. So I'm just going to use this example here. We can see we're revolving this around the y-axis, this being the y, this being the x, obviously, somewhere along here. And then since we're rotating around the y-axis, our representative rectangle will be parallel to the axis of revolution. And now that's a little different than what we saw before when we were finding using washers and discs. Our representative rectangle was always perpendicular to the axis of rotation, okay? And you guys are going to see this come back again in Calc 2, so I just want to remind you of those things, even though it wasn't on the AP exam. You know, that's one of the major difference between washers and, I almost said washers and dryers, washers and discs and a shell method, okay? The shell method is parallel to your axis of rotation. Okay, and what that means is, since this is actually going to be parallel to the axis to the y-axis, we're going to integrate with respect to the other variable, which in this case would be x. So we're going to integrate everything in terms of x for this particular example here. Okay? So we can see here it's going to be 2 pi. Now they use the function p of x as the radius, okay? And that's always going to be from the axis of rotation to the representative rectangle, okay? So I'm going to make a note of that. P of x, which is also the radius, is from the axis of rotation to the representative rectangle. Okay. And you could see here, P of x, as we said, is the radius. H of x would be the height of that rectangle. Okay. And we're just going to probably use the variables here. Radius, we'll use r. Height, we'll use h, just to simplify the process. Okay. So I know here it's going to be the integral from 2 pi rh dx. Okay. So we have our circumference, we have our height, and then we have the thickness, and we're going to add them all up once we find the volume of each one. Okay? So that would be a vertical axis of revolution, very similar to a horizontal axis of revolution. Here's our indication that it's going to be a horizontal axis. So now, since it's going to be rotated around the x-axis, or I'm just saying x in this case, everything is going to be in terms of y. So the thickness of our representative rectangle is delta y. The height is now really not the height. It's kind of like the length. So you can turn your head if you want to. Just know that this would be the height. This would be the width. And now our radius is still from the axis of rotation, which would be x, to our representative rectangle. And that's really important as we move off the axes, okay? As we move off the x-axis and the y-axis to a different line of revolution, that is really, this is super important to know where the radius is going to be, okay? So let's look at a couple examples here, and then we might make this into 2 parts. We'll see how far we get, and we'll keep cruising and go from there, okay? All right, so here's an example. You can find this in your math notes. I've attached that to the to Google Classroom. You can take a look at that. Here's our function. Okay, clearly this is a quadratic. It's a parabola. It's going to be opening up. Since our a value is positive, it's going to be shifted up 1 unit. Okay, and these are the boundaries that we're working with. We have y equals 0, also known as the x-axis. We have y equals 0, which is also known as the y-axis. And we have x equals 1, which is going to be a vertical line, and we're going to be revolving this around a y-axis. So as we said before, with all these volume problems, you want to get a good picture of what this looks like. Okay, here's our parabola. It's opening up. We're going to bring it down here at 1. Okay, so we know that if we take that one value, we plug it into the function, we get y is equal to 2. So this point here is going to be 1, 2, 1, 2. Okay, and here's our boundary of our y-axis. Here's a boundary of our x-axis, and then this is the figure, the region that is being bounded by our criteria here. Okay, this is going to be revolved around the y-axis, so I want to indicate that by putting down my symbol here. And now that tells me a lot. That tells me that our representative rectangle is going to be parallel to that, so it's a vertical representation here. Okay. And now what I'm looking at is finding the pieces that I need from my shell. So the pieces that I need from my shell, there's 2 things. One would be the radius. The radius, as we said, is from our axis of revolution to our representative rectangle. That would be our r value. And then the height would be from here to here, which would just be the function itself. Okay, so we have r is equal to x. That is our distance from here to here. We don't know. It would change with our representative rectangle. And our height is going to be the function, which is x squared plus 1. Okay. So now I'm ready to find the volume. I'm going to take 2 pi. I'm going to put 2 pi out front. Okay, everything is going to be in terms of x because here's our delta x here. Okay, so I'm going to be integrating from 0 to 1, and it's going to be 2 pi times the radius, which is x, times the height, which is x squared plus 1 in terms of x. Okay, so now this is we're gonna integrate and then evaluate. All right, so I have 2 pi. Actually, before we do that, I noticed that it might be helpful if I distribute the x and get it into a little bit more of a user-friendly format. Now I'm ready to do some calculus. We're gonna add 1, multiply by the reciprocal, add 1, multiply by the reciprocal, and we're going to evaluate that from 0 to 1. Okay, as we work that through, I have my 2 pi here. I'm going to keep that on the outside. Now I'm going to evaluate. It's always the upper bound minus the lower bound. When I plug in 0 there, I just get 0. And now we do a little bit of calculation, a little bit of math, and I get 2 pi. Let's see, 1 to the 4th is 1. This is 1/4. This would be 1/2. 1/2 and 1/4 is 3/4. And then we multiply those together, we get 3/2 pi units cubed. Okay, so what's interesting is, and if we had the time to do it, I would actually take this guy and I would show you using the washer method, we would get the same value here. So some people like the shell method, and you guys may as well. Once we start practicing it, you'll see. If we actually wrap this around the y-axis like we just did, this would have to be a washer, so we would have a hole in it. Okay, and the calculations would be a little bit more involved. Not hard, just a little bit longer, not as efficient as what we just did here. Okay, so that's our first example. I'm going to make this 2 parts of, this is going to be part 1 of 2 parts. I'm going to come back with the second example where we spin it around the x-axis, and also show you an example where when we come off the axis, y-axis or x-axis, what that looks like and how we figure that out. Okay, so I think we're off to a good start here. Feel free to watch it as many times as you wish, and make sure you watch part 2 for the last 2 examples of the shell method. Okay, guys, hope all is well again, and I will talk to you and see you soon. Bye.